Hey Econ 200. In this video, I'm going to go over answers to the problems in Chapter 6 of the textbook that you suggested you needed help with based on your responses to the survey that I sent out. I'm going to go over 4 problems. The first is from Facts and Tools. It's going to be problem number 1. So the wording of the problem, the setup says, as we saw in Chapter 4, economists' idea of equilibrium borrows a lot from physics. Let's push the physics metaphor a bit further. Here we focus just on the supply side. For each set of words in brackets, circle the correct choice. So part A, I've written out part A and part B below. When the government subsidizes an activity, resources such as labor, machines, and bank lending will tend to gravitate either toward or away from the activity that is subsidized, and will tend to gravitate either toward or away from the activity that is not subsidized. So I've set up a couple of graphs here, and let's start. This one's going to be for part A to think about subsidies. Remember that when you have a subsidy, we can analyze that by drawing a subsidy wedge to the right of equilibrium. And wherever that subsidy wedge hits the supply and demand curve, that's going to give you the quantity of units that are bought and sold in the market. So notice what's happening. When you start at the equilibrium, if you subsidize this market, what's going to happen is you're going to get an increase in the number of units that trade. That means you're moving to the right along this supply curve, okay? And that means that firms are producing more of the product. If they're producing more of the product, that means they're going to need more labor, more machines. They're going to be borrowing more money from banks. They're going to need to buy more buildings, okay? And so that all suggests that when you have a subsidy, it's going to move resources towards the good that you are subsidizing, okay? Now, what will it do for goods that you're not subsidizing? Well, the resources that are coming into this market have to come from somewhere. You don't just magically wave a wand and create more resources that go into this market without affecting others. So the place they're going to come from is going to tend to be markets that are now less attractive to produce in because those other markets don't have the subsidy that you have in this market. So resources will come into this market, but they will be shifted away from activities that are not being subsidized. Now, given the answer to part A, the answer to part B should be really clear. It's exactly the same wording, but now we're talking about taxes instead of subsidizing. All right, well, when you've got a tax, you place a tax wedge to the left of equilibrium. Where that hits the supply and demand curve, that tells you the new quantity of units, the quantity QT when you've got a tax. And notice that now there are fewer units being produced. Why? Well, the cost of the seller, if you impose the tax on the seller, the cost of the seller has increased. So they're not going to be willing to sell as many units as they were before. Or if you impose the tax on the buyers, their demand curve is going to shift down. They're not willing to pay as much to the sellers as they were before because now they have to pay some of that money to the government. So either way, sellers end up getting a lower price than they did before the tax, and you end up seeing fewer units produced. If fewer units are being produced in this market, that means that they don't need as much labor or as many machines or buildings or loans from banks. So that means that when you tax a market, resources will move away from that market. Where are they going to go? Well, again, just like you don't magically create resources by subsidizing a market, you don't magically make those resources all disappear when you tax a market. Those workers are going to want to go somewhere else, get jobs in another market. Banks are going to want to lend in other markets and so on. And so they will gravitate toward activity that is not being taxed. So that's the answer to problem 1 of Facts and Tools. Now we're going to move on to the thinking and problem solving section. And I'm going to go over questions 6, 7, and 8, the last 3 that we had in that in that section. So let me move those pages. All right, question 6. Consider the following diagram of a tax, and they have something similar in the textbook. The triangular area representing deadweight loss is highlighted. I didn't highlight it here just to make it easier to look at. And also, you'll notice that they're using yellow, and I don't have a yellow highlighter. Okay. So the deadweight loss is highlighted, and its dimensions are labeled base and height. Recall that the formula for the area of a triangle is 1/2 times base times height. This is a multi-part problem. Part A, in order to calculate the deadweight loss of a tax, you don't need the entire demand and supply diagram. You just need to know, turning the page now, 2 numbers, the base and height of the deadweight loss triangle. What is the real-life meaning of the base? What about the height? Okay, so they're asking in words, not in economic speak or in geometry, what does this base represent? Okay, well, that base represents the tax per unit. In words, that's what the base of this triangle is. The government is imposing a tax per unit in the market, and this tax wedge, which is the base of the triangle, represents the amount per unit that is being charged. What about the height of the rectangle? Well, in equilibrium, you would have this quantity of units that are traded. With the tax in place, you have a smaller number of units that trade. And so the height of this triangle is the difference in those quantities that are trading, or the reduction in trades. That's what the height is. So that's part A. Part B, can you turn your answers to part A into general rules about the deadweight loss associated with taxes? Try phrasing it like this, but replacing the part in brackets. And in the brackets, they have either base or height. So I will read out the phrase, and I'll just put in the terms that I've already written out. The larger the tax per unit, the more deadweight loss is generated by a given tax. And similarly, the larger the reduction in trades, the more deadweight loss is generated by a given tax. And all that's we're trying to get at there is the more you tax something, okay, the higher the tax per unit, the bigger this base is going to be. All right, and so that, holding the height constant, that is going to increase the area of this triangle, the deadweight loss. Similarly, holding the base constant, if you increase the height, if you have more and more reduction in trades, that also results in a larger deadweight loss. Because remember, the area of this triangle here, that deadweight loss, that's telling you about the value of the trades that would have happened if you didn't have the tax. But because you've imposed the tax, those trades are no longer happening. Part C. Holding the base constant, the height and thus the deadweight loss would get larger if the demand curve or the supply curve were more blank. All right, well, I'm going to show you with the by just changing the demand curve, but the same would hold for the supply curve. The word that they're looking for to fill in the blank is elastic. The more elastic either or both of those curves are, the larger the deadweight loss is going to be. Holding the base constant, the height is going to be bigger. All right, so let me just sketch those out to the right here. Price and quantity. Price and quantity. Now the supply curves for this market, I'm going to try to keep them more or less constant. All right, so we've got supply is basically the same elasticity in either of these two markets. But in this market, I'm going to make demand relatively inelastic, and in this market, I'm going to make demand perfectly elastic. So this is the more elastic curve. Okay, now let's impose a tax of equal size in these two markets. So I'm going to give you a tax wedge that is 1 inch. Call it whatever you like in dollars, but I want to make sure that the tax wedge is the same in this graph as it is in that one. Okay, so with a 1 inch tax wedge, we're getting this distance away from the equilibrium. But for a 1 inch tax wedge on this graph, notice that we're farther away from the equilibrium than we were before. The distance from the equilibrium to wherever the tax wedge hits, that is the height of that triangle. Okay, so notice that when you flatten one or both of these curves, you can't get as close to the equilibrium as you can when those two curves are steeper, right? And so if I made this demand curve even steeper, then I could get this tax wedge even closer to the equilibrium, right? So the more elastic demand is, the larger the height of this triangle is going to be, or the more reduction in trades you'll see. Similarly, you could go through the same reasoning for the supply curve. The more elastic the supply curve is, the greater the height of this triangle. It's going to get harder to get that tax wedge close to the equilibrium. Okay, and then let's see, part D, the last part of this problem. Without having a diagram as a reference, can you answer the preceding questions for a subsidy? Okay, well, we do have a diagram handy, but we'll use the one on taxes here to think about for subsidies. So before, the first question, right, was what is the base when you're talking about a tax? Well, remember, a subsidy is just a negative tax, so you would end up with this triangle on the other side of equilibrium. You'd have a wedge on the right-hand side that would be the subsidy wedge. And the base of that subsidy wedge would not be the tax per unit, it would be the subsidy per unit. Okay? And if there's a tax, you have a reduction in trades. You're trading fewer units than you would in equilibrium. But if the wedge is on the other side of equilibrium, as it is with a subsidy wedge, you're actually increasing the number of trades. So with a subsidy, the height is going to represent the increase in trades. And then you could go through that, making that same, that set of statements in part B. The larger the subsidy per unit, the greater the base of the deadweight triangle. The larger the increase in trades, increase in number of trades, the greater the height of the subsidy, of the deadweight loss triangle. Okay, so that's part C. And then, that was part B. And then answering part C for subsidies, you're going to get exactly the same answer. Now, I can't make the subsidy wedge quite as big, but, right, say you've got this subsidy wedge in this market, you could take that same height of, that same base, and you'll notice that we can get closer to the equilibrium with the same size subsidy wedge when supply and demand are more inelastic than when they are more elastic. So the more elastic supply and or demand are, the more extra trades you're going to get from a subsidy. When supply and demand are relatively inelastic, you get fewer additional trades from a subsidy. Okay, so that is problem 6. Problem 7. Move those. Okay, problem 7. Suppose your state government has decided to tax donuts. Currently, in your state, 300,000 donuts are sold every day. Three possible taxes are being considered by lawmakers: a 20-cent per donut tax, which would decrease donut sales by 50,000 per day; a 25-cent per donut tax, which would decrease donut sales by 100,000 per day; and a 50-cent per donut tax, which would decrease donut sales by 150,000 donuts per day. Part A, calculate the tax revenue generated by each tax and the deadweight loss caused by each tax. All right, now I just realized something, guys. In making this video, I was going to use my phone's calculator to do out the calculations for you so I wouldn't have to write them out. And it didn't occur to me until just now that I'm using the phone to video this. So that's not going to work. Let me grab a sheet of paper. Or three. Okay, so let's begin. We need to, the part A is basically fill in these columns: the tax revenue that's raised and the deadweight loss. So to figure out the tax revenue raised, we need to know the number of units that are still trading and the tax per unit. We're going to multiply those two things by each other, and that will give us the tax revenue that has been raised. Okay, so here for the tax at 20 cents, we've got 20 cents times 250,000 units. And so we're trying to find 1/5 of 250,000 units. TR for tax revenue. That's going to be $50,000. When the tax is 25 cents, we've got 0.25 times 200,000 units still trading. So we're looking for 1/4 of 200,000, and that also works out to $50,000. And finally, tax revenue when it's 50 cents, multiply that by 150,000 units, and that will give us what? Half of 150,000 is $75,000. Okay, so now just enter those. All right. Now, what about the, oh, and just to make that clear on a diagram, right? Here's our tax wedge, and call that, this could be either the 20 cent or 25 or 50 cent. That gives us a quantity of units, QT, the quantity with the tax. There's going to be a price that the buyer is paying, a price that the seller is receiving. The difference between PB and PS is the tax per unit. So when we're calculating the tax revenue, that's the area of this rectangle. And in each case, we're just plugging in a value for tax per unit and a value for the number of units that are still trading, QT. And that's where those numbers come from. All right, now the deadweight loss. That's going to be this area here. And to find that area, remember we need to know what the equilibrium trades are minus the quantity of units that are still trading in the market, right? So, by the way, the units that are still trading, those are the 300,000 units that the textbook tells us would trade in equilibrium. That's QE. And then from that, we subtract the number of units they're saying is going to be reduced in trades based on the tax. All right, so for this area, for the deadweight loss, we need to multiply the tax per unit, the height of well, they're calling it the base of this triangle, times the reduction in trades, which is given in this column, and then we divide by 2. So I'm going to have 3 deadweight losses. Okay, in one case, it's going to be 20 cents per unit. And there are, how many fewer trades? Well, I can tell from here. 300,000 minus 250,000, there's going to be a reduction in trades of 50,000. And we will divide that by 2. This is, wait a second. That is, okay, so 20 cents times 50,000 gives us $10,000 is the numerator, divided by 2, $5,000. Second deadweight loss, if there is a 25 cent per unit tax, the number of trades reduced, well, there's 300,000 in equilibrium minus the 200,000 that we're still trading when we've got that that tax. So we have 100,000 unit reduction. Divide that by 2. 25 cents times 100,000 is 25,000. Divide that by 2. $12,500 will be the deadweight loss. And finally, with a 50 cent per unit tax, in equilibrium, there would be 300,000 trades. With the tax, there's only 150,000. That means we've reduced the trades by 150,000. Divide that by 2. We've got $75,000 is the numerator. Divide that by 2. 37,500. And entering those into our deadweight loss column, 5,000, 12,500, 37,500. All right, so that is part A. Part B, if the goal of your state government is simply to raise the most tax revenue, which tax is preferable? Well, obviously it's going to be whichever tax gives you the biggest number in this tax revenue raised column. That's the bottom row here. So the 50 cent per unit tax is preferable if all you're worried about is how much money is the government going to raise. Part C, if the goal of your state government is to raise tax revenue in the most efficient manner, which tax is preferable? By efficient, they mean the most revenue raised per deadweight loss, or the reverse of that would be the smallest deadweight loss per dollar of revenue raised. Well, your deadweight loss per dollar of revenue raised is just the deadweight loss divided by total revenue raised. And here that's 5,000 divided by 50,000. That gives you 10 cents of deadweight loss per dollar raised. Here you've got 12,500 divided by 50,000. And that is 25 cents of deadweight loss per dollar of tax revenue raised. And finally, if you divide 37,500 by 75,000, you get a deadweight loss per dollar tax dollar raised of 50 cents. So the most efficient tax is going to be the one that gives you the smallest number here, and that is obviously 20 cents per unit. Part D, what other goal might your state government have when creating this kind of tax besides raising tax revenue? Well, it could be that the government is interested less in how much revenue they raise and more in discouraging the consumption of donuts. And the reason why you might do that, it could be just paternalism. You just feel like people don't know what's good for them, and so you're going to encourage them to do what's good for them by raising taxes on them. Or it could be, as we're going to talk about in Chapter 10, it could be that you think that consumption of donuts has some negative spillover effect onto other people. So consuming donuts increases obesity. Obesity increases the the amount of healthcare that's used, and then that drives up everybody's insurance premiums, for example. So it could be that you're just trying to fight obesity. You don't really care too much about the tax revenue that's raised. You don't care so much about the deadweight loss. We'll get to that again more in chapter 10. And so what you're just trying to do is cut back on intake of sugar and fat, and the tax is accomplishing that. Final problem. Thinking and problem solving. Problem 8. How is it that a tax, it creates a deadweight loss by decreasing quantity, but a subsidy creates deadweight loss by increasing quantity? All right, here's what's key to understanding the answer to this problem. You got a market. Suppose you have a market that does not have any taxes or subsidies in it. That means that you're going to be trading at the equilibrium. Okay. Now, it turns out that in this type of market, where there are no spillover effects, the equilibrium quantity is exactly the number of units that you want to trade, because it's the number of units that maximizes total gains from trade. Remember, demand curve tells us how much value are the consumers getting out of each unit that is sold, and the supply curve tells us what is it costing the producers, including opportunity cost, to make those units and sell them to the consumers. And to the left of equilibrium on all of these trades, the value is greater to the buyers than the cost to the sellers. So we want to see all of these trades happen. To the right of equilibrium, the opposite is the case. It costs more to produce than the consumers are getting in value out of consuming. So we don't want to see any of these trades happen. That tells you that the closer you get to equilibrium in this kind of market, the better off everybody is. And so the issue isn't, am I discouraging trades or, excuse me, let me rephrase. The paradox isn't that that increasing trades can sometimes, destroy value. The issue is, how close are you getting to equilibrium? Now, a tax is going to get you away from equilibrium by stopping trades that should have happened. Right? You've got these extra trades where the value to consumers is greater than the cost to sellers, and so you get a deadweight loss by leaving money on the table, basically. Okay. On the other hand, if you've got a subsidy, you end up with this quantity QS. All of those extra trades are trades that you don't want to see happen. The cost to the sellers is greater than the value to the buyers, and the only reason these trades are happening is because the government is paying the buyer and the seller to engage in those transactions, and that is creating this deadweight loss of waste. All right, so that's the reason why a tax hurts the market by reducing transactions. A subsidy hurts the market by increasing transactions. The reason why that can be true is both of them push you away from this equilibrium, and in this case, the equilibrium is exactly the best place to be. Now, that's not always true. We're going to see in our next lecture on positive and negative externalities, the market equilibrium, if there are spillover effects, is not necessarily going to be the socially optimal level of output, or in other words, the place where you're maximizing the gains from trade, the total welfare to everybody in the system. But in this baseline case, it is, and so taxing or subsidizing either of those things is going to harm gains from trade. That is it for Chapter 8. If you have questions about other problems, you can bring them up to me either through email or when we start our mandatory virtual office hours next week. Take care, guys.